Alright, I'm gonna get started with Matlab Lecture 8, and we'll be going into 2D plotting. So, to get started with 2D plotting, I'm gonna make a quick line graph in my editor. So I'm gonna make a file really quick. So I'm gonna start with saying that x equals linspace 0 to 10, and we'll have we'll put, actually I'm gonna do 0 to let's just do that, 0 to 10, and I will put 100 numbers in between. That's a bit big. Alright, 0 to 2 pi, and I'm going to have 16 numbers in between them. Now remember, linspace means that I'm going to be linearly spacing numbers from 0 to 2 pi, and there will be 16 values in there. So this is like basically a different way of doing it from colon notation. And then I'm going to have y equal to sine of x. And to make a line plot, you just say plot x, y. And then when I run this, which I have to save this first. Okay, it looks like I haven't synced that yet. Anyways, I'm gonna name this one basic, or no, sine plot. And when I run this, I'm going to change directory, and then you will have a plot over here. And as you can see, the values go from 0 to 2 pi, so 2 pi is somewhere around 6.2, which would be around here. And here's a sine. It doesn't look perfect because I only have like a resolution of up to 16 digits in between 2 pi and 0. So if I went up here and increased the number, this will look a little better. So say 64, just to be overboard. And when we look at this again, yeah, this looks a lot smoother. Very nice. So let's say you want to put multiple plots into one window. Let's make a new file. So I'm going to have this same one as last time, the same plot. I'm going to make this y1, and then y2 will be cosine of x. Now, okay, so there are multiple ways you can put two different functions into one window. I could just plot both of them on the same graph at the same time. So to do that, I can do x1, y1, x2, xy2, and I need to save this first. And I run this, we have both of these, which is nice. And alternatively, I can specify a hold. So hold means that instead of overwriting whatever I'm plotting, just plot over it. So I could just do, plot x, y, 2. I find this easier than the first way I did it, and you will get the same result. I'm gonna wait for this to load. Yep, and you get the same results. Now I'll just go with the first method since it's different from my notes, so you can get a clear example of how I'm doing this. And then another way you can put two of these in one window is to put it on separate graphs. Now to put these on separate graphs on the same window, you have to use something called a subplot. So let's say if I introduce another function, I'm going to make it different from my notes. So we'll say this is going to be cotangent of x. We'll see how this looks. We can start to specify a subplot. Now, like in the notes, the subplot takes 3 numbers for the parameters. The first one's going to be the amount of rows there are, so I'm going to have 2 rows, because 2 graphs, 1 column, and this first graph is going to be in the first index. And the second index, I'm going to plot the cotangent. So these first 2 numbers are going to be the same. And then plot x. I don't actually need the x here. I could just, do y3 and it will work, but in general, I think it's better practice to specify what you are plotting. Oh wait, no. If you do this, it will just, I believe it will do like that will set the x-axis to linearly spaced values from 0 to 1 or something like that. So okay, it's better if you just specify your x. So if I do this, now we have 2 graphs. Now I know the cotangent graph looks like this. Yeah, that's what it looks like. So yeah, let's see if I can do a different kind of graph. Maybe I can do sine x times cosine x. That'll be fun. And let's see what that gives us. And we'll let Octave think a bit. I've noticed it's a little bit slow with Octave. It's definitely faster at Matlab, but Octave does the job. So I'm gonna wait for it to do something. Is it doing anything? Oh, there's an error. Alright, it does not like that. Okay, let's try that again. There you go. I just changed it to element-wise and it works now. That looks pretty cool, if you ask me. Now, for this first graph, let's say you don't really understand trigonometry and you don't know which one of these is the sine and the cosine line. We'll make that more clear if we add a legend. So over here, I'm going to add legend. And for the first part of the legend, I'm going to... Okay, so I'll put sine x and then cosine x. I think this works. We'll see. And as you can see, the blue one is sine x. It makes sense because at sine, when x equals 0, sine is 0. And when x is 0, cosine x equals 1. And you can see we've clearly shown the difference between them. I went over a little bit of customization options for the legend, so I can say, I can remove the box and just say box off. I think there are different ways of doing that. Oh, the box is still there, alright. Forget that, there's the Matlab thing. And we'll see if I can put it in a different amount of columns. So say num columns. And let's say I want 2 columns. Oh, it didn't work. Alright, so I might have listed some Matlab only parameters, but in Matlab, this will allow you to have the elements of your legend in 2 columns instead of them stacked like this. But it's okay. It looks fine. I don't think you really have that much issues customizing unless like you probably won't have to customize the legend unless you really have to because maybe it's blocking something, but right now it looks fine. Now I'm sure when you were in school your science teachers and math teachers made a really big fuss about properly labeling the graph. So as you can see, we don't have any axis titles or like graph titles, and that's not good. So to fix that, I'm gonna add in a title. So the title of the graph, I believe the parameter goes like this. Actually no. The title of the graph will say this is actually, do they? Yeah, okay, so each subplot has a different title. So I have to put in the title here. title, this one's going to be sine and cosine graph. I'm going to capitalize it. I'm going to capitalize this. And this one is going to be sine x times cosine x graph and where did my titles go? Okay, maybe I did do this wrong. That is really weird. I'm gonna look at my notes really quickly. Yeah, that should have been right, so I'm not exactly sure what happened there. Let me see what happens when I take... Oh, I just saw it. It disappeared. So if I do it like this, that is really weird. Alright. Hang on while I troubleshoot this. That is so weird. It appears and then it disappears. Maybe in Octave you can't do this. I mean, this works perfectly fine in Matlab. This is a problem I've only had with Octave. So this title only seems to work if it's the only plot on there. So if I do this, like say sine graph, what the heck? It just disappears on me. I saw it appear momentarily in other... there you go. Alright, so if I put this after... Okay, now it works. I did not know it was a mandatory thing until now, but you have to put your title after your plot. So it works. And now it works, I guess. Now let's add the axes titles now. So I'm going to say X label for the x-axis. And I'm not really... okay, yeah, we'll just say it's going to be radians. No, that's not right. The units aren't in radians. So I'll just say units. And for Y label, we'll just amplitude. And then let's do the same, let's do the same thing for and now we have axis titles, so that's nice. And there are a few other options you can do with these graphs. I'm gonna try to see if I can put a grid on these. So grid on. Grid on. Yeah, that is pretty fancy. And I think I can also do minor grid lines. So if you do grid minor on, this should turn on the minor grid lines. Oh, yep. Look, that is so detailed. You can almost make out every single point on there. Let's make the subplot bigger. I'm going to demonstrate something. So if we can make a graph bigger than the others, if we specify it, so I'm going to show you what I mean. So let's say this is going to be 2. Actually, no, let's do this on a different file. I'm gonna make a new file. I'm gonna call this a triple plot. We're going for the big leagues here. And then I'm gonna make a y4. And this is going to be sine cosine x. So a little plot twist there. And we'll keep this on the, let's put this on the index 3. So this will make it so on a 2x2 matrix, 3 means that it will appear on the top right. And for this one, I'm going to make it take up 2 spaces. So 1 and 2. I think this should work. If not, I think I know what I did wrong. And then for our fourth subplot, 2, 1, 4. Oh, this should be 2. 2, 2, 4. I'm gonna plot x, y4. I'm going to copy this over. And let's see if this works. Okay, so I was wrong, but it worked, which, lucky me. So this is the first index of a 2x2 matrix. This side, this subplot is 2, 2, 1, 2. Is 2, 2, 1, 2. This is 1 right here. Like this area is the first index. This area is the second index. So if I put them together in a vector, then it combines them, which is kind of cool. And this is position 3, well, index 3 and index 4. Now, I can change how this looks. So say if I do 1, 3, like they did in the MathWorks demonstration, and I put this on 2, we should see, yep, it will look like this. So this is 1, 2, 3, 4. And I told this to take a 1 and 3. It's 2 and 4. Now I'm sure I can mess it up some more, but I don't really want to. Let's try this. And make a 3x3 matrix. Just because I can get some extra room in here. A 3x3, I'm gonna make this one take up 1 and 2. I want this to take up 3, 6, and 9. I'm going to make this one 4, 5, 7, and 8. So this should take up the bottom left. So let's see what this looks like. Yes, that looks really good. So we have our first plot here, the sine and cosine graph, taking up indexes 1 and 2. And for indexes 3, 6, and 9, we have this sine cosine graph, which this works well because the amplitude is kind of big. Well, the amplitude here is a little bigger. And for this one, we have 4, 5, 7, and 8, and this takes up a big corner over here. Unfortunately, it looks like the title is kind of conflicting with the X label here, but just not much we can do about that. Maybe if you, yeah, so maybe you stretch the window, then it doesn't really block the other one anymore, so that's good. I believe there is a command to like set the default size of the window, and it shows up. Maybe it's part of the figure, which I'll do that now. So the figure command allows you to name windows and to refer to them later. So if I go over here, say figure, name, and I give this window a name. So we'll call this trig. When I make this, you'll see that the window is now called trig graphs. And I think I can put an ID over here. So say, okay, so we can assign F1 to this figure. And we'll say F2, which should be a different window, equals figure, and for this name, let's call this trig graphs 1, and then trig graphs 2. And let's make a Y5. This one is going to be, let's do Y1 minus Y2. And we can do something like this. So let's say if I want to work with Y5 first, I'd say figure F2. And now we're working in the scope of F2. And I'm going to say plot X, Y5. And then that'll be there. And I'm going to switch the scope to F1 for this. And if we do this, 2 windows should pop up. So this is trig graphs 1. This is what we had earlier. Whoops. And it's kind of squished. So we have this. And in trig graphs 2, we have a second graph here all by itself. So you can use the figure the figure command to make different windows have different names and identify them later so you can select them. And as you can tell, when you use this with hold and subplots, this becomes really powerful. You can put a lot of different graphs in a lot of different places. You can put a 3D graph here, 2D graphs here, whatever, and stuff like that, which we'll go over 3D graphs in a future lecture, but not now. But you can put as many graphs, which is pretty useful. Now, there wasn't that much more I wanted to go over in this lecture, but we can go over the different kinds of graphs that there are. So I'm going to make a new file, and we'll make these all different types of graphs. So we'll say x1 equals 1 space. Actually, we'll just use colon notation. 0 to 10. Actually, we don't even need a, so the first graph I'm going to make is going to be a bar graph. We don't actually even need an x for this one. So let's say if we do y1 equals some random values, so say like 5, 6, 3, -9, why not, 10, 4, and then I say bar, let's make this a new figure, f1 equals figure name bar, and then I put bar y1. We should get a nice little bar graph. I'm going to name this file graph sampler. So you see we have a bunch of bars here, and that's cool. And we can do different types of graphs. So we have bar graphs, histograms. A histogram, okay, I'm not really too sure on the difference between histogram and bar graphs. It's been a while, but I believe histograms are supposed to show data differently, like in a probability kind of way. And there's a pie chart, so let's do a pie chart right now. Say y2, we don't even need an x for this one either. y2, and we'll make these different percentages that equal to 1. So let's say this equals 0.1, 0.3, 0.5. That adds up to 9, and we just do 0.1 again. And then pi y2. I'm gonna make a different figure. When I do this, I should get a second window of a pie chart. So yeah, that's pretty cool. I believe there's a way to label the data there too. It might be using the legend command. Yeah, I think it is legend. So let's do a different kind of graph again. Let's do a scatter plot this time. So now we actually do need X for this. So I'm gonna have a bunch of random values here. Actually, yeah, let's just do a bunch of random values. So I'm gonna say 1, 5, 7, 3, 8, -2. And for y3, we'll have some more random values. We'll say 8, -1, 2, 0, 0, and 10. I'm going to put some semicolons on this, so I'm going to make this a new figure. So figure F3 name. I'm going to call this a scatter plot. And when I do this, scatter x3, y3, we should get a nice little scatter plot. Yep, so it looks like that. You can actually make a linear plot look like a scatter plot because the linear plot can actually plot discrete points. So if I do that, say f4 equals scatter plot 2, that is 1. And if we plot those x3, y3, this might be kind of hard to see because I think the points won't be very clear. Oh, okay, no, I'll just pretend it's a line, but obviously it's not what we want. So let's say we want this scatter plot to look like a scatter plot, and you're not supposed to connect the dots here. I'm sure if you try to do that in science class, your teacher would have probably wanted to kill you. So don't ever connect the lines to scatter plots. So I'm going to say O. So this O means that I'm going to make this make the points visible as little dots, just like that. Like it looks exactly like a scatter plot almost. And so this over here kind of lets you change the format of the lines and the points. So if we do -O, it will connect the dots, the dashed lines. Okay, no, this isn't one of the dashed lines. This is just a solid line. So if I want to do dashed lines, I do something like that, 2 dashes. You can also use colon for a shorter dashed line. So look at that, that's pretty cool. And you can even change the color. So let's say I want it in magenta, so I think I just type in M. So it makes these in magenta. So it's not super intuitive what these letters mean over here, but I included a link in my notes that allows you to see all the different letters and characters that Matlab accepts as format. I believe Octave would do the same thing. So that's how you change the color and the weight of your lines and the points, how they look. So that's pretty much all I have to offer for this lesson. 2D plotting, it's pretty easy. It looks really cool, so I would definitely try to get good at doing it. You have really good ways of displaying your data in the future, especially to people who don't use Matlab or Octave. People who you're presenting your research to, this is very useful for that. So since no one actually came to the lecture today, I don't think there are any questions, but as always, I will be in the server and I will answer any questions that you do have in the meantime. Well, thank you for coming to my lesson.